very good evening and good to see you all. On behalf of our institute, I would like to welcome you all to the Southeast England and London Home Counties branch event. Today we have with us Dr. Rodrigo Perez from SENER Naval Shipbuilding, who will be discussing us with the topic Evolution of Ship Designs and Future Ahead through Artificial Intelligence. A few words about the speaker. Rodrigo Perez has worked for SENER, a Spanish engineering company, during the last 8 years. He had the opportunity to partner with several shipyards, including 5 years in the UK, as a main liaison for the development of new fleet of British aircraft carriers. He has also been in customer engagements in various other countries around the globe. He was the CAD and PLM consultant for SENER, as well as the project manager for SENER clients in North America. He is currently the head of Naval Shipbuilding Area Manager in SENER. Combining his activity in the private sector, he is professor in the Marine Engineering School of University Polytechnic of Madrid, and he is lecturing in shipbuilding history as well as other subjects related to steam, gas and steam turbines. He has also accomplished several seminars related to shipbuilding and naval sector, and has published several books and written more than 50 technical papers about marine engineering. Let's welcome Dr. Rodrigo to deliver the presentation. And one more point, those who are joined online can ping your questions through Slido. So there is you should be seeing on your screens. So you can log in with the number R575 and ping your questions if you have. All right, over to you. Thank you.
Thank you very much, Viju, for your kind introduction, and thank you everyone here for attending, and the people that they are attending through WebEx. It's my pleasure to be here. So this presentation that I'm going to carry out tonight is a presentation that will cover the evolution of the ship design through the old times to the future, through the current situation for the CAD systems, the software that they have been using to generate the hull forms, the outfitting of the ships, the hull forms, through the structure, HVAC ducts, and the rest of the accommodation of the spaces. So the first thing that I would like to mention is, in this slide I have tried to put a picture that I took years ago in the Irving Maritime Museum, close to Glasgow, nearby to Glasgow. So in this picture is stated that every ship starts life in the mind of a designer. I think that this is the main objective of all the people that they are attending this topic. Is all of us, we know how the ship needs to be designed, and the only thing that we require is to have a software in order to design of the best way this ship, ship, boats, offshore platform, whatever is the structure that we are going to design. So the current design, here we have people attending that they are expert in finite element methods. Here we have a complete ship designed through a software where we can see all the pieces, that all the bill of material can be exported to a finite element solver. It can be also generate all the outputs. So this is the traditional way, current way to do the stuff in the shipyard. So the aim of this presentation is to explain what is the future in terms of the ship design. So I'm going to try to carry out the presentation as quicker as possible in order to allow you some time for questions and some debate. So we are going to start with the past. Probably some of you recognize this photo I took in Portsmouth. Most of you recognize that is the Mary Rose. And here we can see some of the elements that there are the constitution of the shell of the Mary Rose. So in the past, the ship design was carried out a bit of experience by the master and the apprentices. And here, for example, I have stated that the fathers of the naval architecture, probably I consider that is Pierre de Bouguer, that in 1746 he published the first book of naval architecture. It was the one called Traité du Navire, which, among other achievements, first explained the use of the metacentric as the measure for ship's stability. This was the first person that started defining some aspects of the ship design. We can consider that Frederick of Chapman also, after, I think that was a couple of years later, and Pierre de Bouguer also wrote a book about the metacentric. Another person that also was working with or developed the ship design was William Froude, that in the 19th century turned his attention to the stability of ships in a seaway, and in his 1861 paper to the Institution of Naval Architects became influential in ship design. All of you know him as was the person that established the towing tanks, and there is one of the first towing tanks that is also in Glasgow that can be visited. It's a museum, and also you can see some of the experiments that he carried out in the 19th century. So we consider that there were the fathers of the naval architecture, and probably we can say that the first people that they were developing ships on a, we can say, traditional way, but with a lot of techniques, were the Romans, where the ship frames were produced based on templates which could be reused several times. These techniques were perfected by the Venetians in the 13th century, and probably some of you that has visited Venice remember the Arsenale, where there is a museum also as part of the Italian Navy. Also, they have a space where you can see some of the technologies that they were using at that time. That frames of that moment that were being reused during the length of the ship were defined in terms of tangent continuous arcs, circular arcs that is well known by us, known today as the non-uniform B-splines, rational B-splines, called the NOBs. On that time, the ship hull was obtained by burying the frames along the keel. We also can say that at that moment there were not drawings. The first mention of drawings, as I have get, it was in the 16th century here in England, where they start establishing drawings in order to define a ship design. The earliest available mention of a wooden beam being using to draw smooth curves, our splines, our B-splines, seems to be from the 18th century, 1752. So we can say that until the 18th century, it was not really a ship design engineering, as probably you already mentioned. That in that photo, in the first photograph that I placed, it is Pierre Bercier, some of you probably recognize. He was the first person that developed a software, a CAD software, in order to generate surfaces. It was in, if I don't remember wrong, it was in 1950s in the University of Paris, where he defined the Unisurf, the first software in order to define surfaces. From that moment, the computer, the software has been, we can say, evolving or has been implemented, developing through the different centuries, and we are going to establish what is the latest advantages of these softwares in order to generate the hull forms and all the elements that they are part of the ships. Just to mention that during the 1960s, the first shipbuilding software that was defined in order to generate ship design, the first CAD software, was Foran, was a Spanish software that is still being in use, and from that moment it was several other CAD vendors that they have been developing other tools. Later on we will see all the history behind the CAD tools and all the names of the companies that have been developing during the years this technology. Just mentioning that the ship internal arrangement has been traditionally created by modeling full-size or scale mock-ups. It was until the 1980s where the shipyard is still creating mock-ups for the piping, machinery, HVAC ducts, cable trays. So until the 1980s, the people did not start using software packages in order to manage the outfitting and the electrical. So the right bottom picture is the one that I have taken from an old shipyard. Is the lofting room where the people can generate in the, I think this photo is from the first part of the 20th century, where the people design the ships in a scale 1:1. Later on, through the ships start build bigger and bigger, they start using other scales, 1:10, 1:5, and it was a moment that it was not enough space in order to define all the logbook of the ship, and they start using the computers. So the first steps in the use of the computers for ship design, we can say that it has not been easy. I think the development of this technology has been moving through the years through the technology of the computers. Probably some of the attendants here remember the blind punch cards and the magnetic tapes that they were using in order to interact with the computer. It was in the 60s, 70s, where the interaction with the user were through punching cards or magnetic tapes. The graphical user interface, videographic, computer-generated pictures, they were from the late 70s, beginning of the 1980s, where the people start defining, the ship through mouse and through an interface, alphanumerical interface through the computer. In the 80s, they will start using the databases with the easy-to-use modern access databases, with the early search engines, spreadsheet, drawing programs, and in the 90s and late 80s and beginning of the 90s, we start with the birth of the numerical control machines. This photo I took in another museum, where it was an example of a mock-up, in a scale mock-up of an engine room from a vessel, where it was defining at the beginning of the 19th century. So as you can see, all the man-hours devoted in order to get a mock-up. This mock-up right now is something simple to create and managed by the technical offices. So the question that we need to ask is why the technical offices and the shipyard, they are using softwares in order to develop the ship design. So we can say that the aim of the advanced tool for ship design, there are computer aid design, manufacturing. They are also engineering softwares in order to manufacture all the information that we can get from the 3D model. We can have the full ship in 3D in a unique database in order to get access to all disciplines and have all the accuracy that we get from the data. We have also object kernel, oriented kernel. We have also distributed databases. We have several we can say advantages in the way to use the CAD system. We have also a high quality modeling and visualization, automatic and robot production in order to send information to the CNC, to the control numerical machines, to the vending machines, to all the information that needs to be manufactured in the workshops. We can also have distributed and concurrent engineering. In the past, the shipyard produced everything, from the engines to the ship itself. But right now, the shipyards try to reduce the fixed costs and they subcontract almost everything. So now there are several actors playing the same game. So we have ship owners, we have technical offices, shipyards, classification societies. All of them, they need to work on a collaborative environment. So this collaborative environment is done through the concurrent engineering. Also is required by the softwares to have plugins with other CAD vendors in order to export to another finite element method solver. We can also generate information through fluid dynamics or computer fluid dynamics software. So we need to interact each other. So this is why we have the advanced tools in order to design the different ships. This slide, this picture, I have defining. I hope that is correct because I have been investigating, researching during the history of the different CAD softwares in the market. We can see from the 1965, we have the first one that was Foran and Autocon. Probably some of you remember Autocon, that Autocon, Steerbeer and Sifco, they joined in the 90s and became the Tribon. Tribon later on became Aviva and Aviva Marine, and now Aviva Marine has been bought by Sifco. We have also Kalmatic and Nupas from the 70s, joined with Nupas Kalmatic, and now they are Kalmatic. We have also PLMS, we have also Napa, and we can see also how the evolution of the different softwares through the history and the different possibilities of using different softwares in the market. So this is the past. We have done very quickly how has been the chronology of the ship design through the history, and in the present, the question that we need to ask is how we consume the data that is generated by a CAD system. So here the first thing that I have placed is two images. One is the 3D mock-up of a CAD solution, and in this case is foreign. All the images that I show are images from the CAD foreign. The other image is the real ship. Some of you can think in the digital twin. Later on we will talk about the future, and the digital twin is one of the aspects of this new implementation. So we have, as probably all of you know, the different disciplines that we have through the ship design, starting from the initial and basic design, hull structural fitting, electrical accommodation. We have also the concept design, basic design, detail design, production, operation, and we have the different, we can say, modules that they can be incorporated in a CAD system. We have, for example, for initial design, hull force definition, general arrangement, and naval architecture calculation softwares. We have also, for the definition of the production detail design, we have hull structural fitting and electrical. We have the standards, the 3D model, generation of the 3D model, through the build strategy if it's a structure, through spools and isometrics if it's in the case of a fitting and electrical, and the exploitation and the manufacturing and the production of the vessel. We have also here several actors that there are also participate in the ship design. We have the security, change and access control, quite important in the case of the Navy vessels when we need to grant the security, the access, that nobody interact with some data that is classified. We have also the collaboration engineering. We have also the PLM integration. For the people that they are not familiarized with the acronyms, PLM is Product Lifecycle Management. Sometimes we will talk about ERP, enterprise, different type of software packages in order to handle the information. We have also the configuration management in order to handle the information as it is required by each of the participants of the ship design. We have the interchange of data, very important, how we consume the data by the different actors, how we have the legacy data created, and also the virtual reality. Later on, we will stop particularly in this aspect of the ship design. So, something that is quite important in the ship design is to get the outputs. In this slide, I have tried to put all the different outputs that we get from the different stages of the ship design, starting from the initial and concept design, through maintenance and operations, through all the basic design, detail design and production. The different design stages, depending on the country that we are, could change. In Asia, in South Korea, for example, they name differently. What for us is the detail design, for them will be other type of the ship design. But here I have tried to place all the different stages of the ship design. So from the initial design processes, we can generate from the hull forms all the damage stability criteria. We can define also the hydrodynamic analysis, intact stability analysis, power estimation, launching information. We have from the basic design, we can generate all the major steel surfaces. We can also generate the general arrangement. We can generate also the classification information, the classification drawings for the classification societies. So in the detail design, we can generate the assemblies, we can generate the spools, isometrics. So at the end, through the different ship design stages, we can generate all the information and always using software. I do not know any shipyard in the world that they are not using a software right now. All of them using software because it's the quickest and cheapest way in order to generate all the information for the ship design of the vessel. So very quickly we can generate some of the information to produce the vessel, from the damage stability criteria that we have on the left to the classification drawings to be classified by the society classification, and generate the hull forms. We can generate the structure, the fitting, the electrical, in order to get a complete 3D model. In this 3D model we can interact different elements and get the information that we required. We have also the virtual reality softwares in order to access to the data by a simplified manner, that with we can say glasses, gloves, we can interact with the model, we can do some training, we can detect some errors, we can do the design review through these software applications, so we can handle all the information on a very easy manner. So as regards the ship design, we have also generate customized links in terms of generating information. Here is an example that I have created in order to see how we generated the information. We start generating the hull forms. After that we generate the shell, we generate the shell plates, we can generate frames, we can generate transversal stiffness, we can generate information from the pipelines, from the HVAC ducts, we can generate classes, collisions, automatically generated the penetration in order to allow that a pipeline penetrate into a watertight bulkhead. We can generate the spools, isometrics, the nesting information, the profile sketch. We can generate the arrangements of the data. We can also generate all the bill of material, all the information that is required for the CNC machines, and also information for vending machines or manufacturing the rest of the vessel. So this is currently how we get in the software and how we can manipulate information as it is shown. So I need to go quite quickly. If we need to say what is the traditional way of working in terms of generate the information, we can say that right now the paper is vital, it's mandatory to generate this information. And what is the problem right now? We have the technical office generate the 3D mock-up. This technical office send to the workshop the different outputs, and the people in the workshop manufacture the vessel. What happens? Someone, the project manager, can realize that there is a problem between the mock-up and the outputs and the information that we have. And sometimes, what is the problem? That someone is very angry because they consider that they have made a mistake. So there are mistakes that can produce a delay in the delivery of the vessel, and also it can be a high cost in terms of building the ship. So what is in this case the consideration of the future? That probably the paper is not going to be vital, it's going to be a paperless design. We are going to generate the information using the new technologies. So the next part of the presentation is going to be, we are going to talk about the future and embed artificial intelligence inside the software. So the first thing that we need to mention about the future is to mention some words from Stephen Hawking. I think that was his last presentation in 2007 before he passed away. It was in Lisbon. If some of you remember, he was not in Lisbon, he was like a, we can say, hologram that he provided the conference, and he said that perhaps we should all stop for a moment and focus not only on making our artificial intelligence better and more successful, but also on the benefit of the humanity. With this sentence, the information that I would like to get from here is all of us need to interact between each other and develop the software in order to get the better tool for benefit of all the participants in the ship design, and at the end for the participants of the society. So how we can get that, how we can consume the artificial intelligence embed into the engineering softwares. So for our point of view, there are 4 pillars. The first one is the collaboration. We need to collaborate each other because probably some of you are experts on the autonomous ships. the autonomous ships, they are not capable to use if we do not collaborate all together. We can have a sensorization of the vessel, but if we do not have a big data consuming the data, they will not be worth it. If we can have all the information of the software prepared, but if we do not have the people ready to consume this data, it's not worth it. So the collaboration is vital in terms of the artificial intelligence embedded into the systems. The co-creation, the change of mind, and the strategy. Very important for all of us is to change the mind and try to use the artificial intelligence in the best way. It's something that we cannot stop. It's the Industry 4.0. It's the next generation of the software. So all of us need to collaborate, and the people that they are not, we can say, pro these new softwares, probably they need to change their mind in order to consume the information that we will get. So the roadmap for a generic CAD/CAM sim software, we can say that is apply the technologies 4.0 embedded into the system. Later on we will see what are the more important. The artificial intelligence embedded into the system is important to collaborate, to have partnerships with different companies in order to get the best result. In this presentation, I need to show you something, and I'm going to show the partnership that we have established, SENER with IBM, in order to get artificial intelligence embedded into a shipbuilding CAD software. And also the model recognition. I will not stop in the model recognition, just to mention that one of the aspects that is key for the shipyard is through laser scanning generate all the mapping of the ship, and later on we can generate the 3D model from this recognition of the model. So there are so many advantages using the new technologies, but I will stop just in the part of the artificial intelligence. So the value for the digital transformation in shipbuilding, I have split it in 3 different pillars. The one is the characteristics, the challenges, and the technologies 4.0. The ones that they are marked in red are for us, or for our opinion, the more important. For the characteristics, innovative, competitive, life cycle. For the challenges, false transformation, legacy data, people and processes problems. And in the case of the technologies 4.0, system integration, virtual and augmented reality, big data analytics, and modeling and simulation. I cannot stop today in each of them. I'm going to pay special attention in the part that is related with the artificial intelligence. So, if we stop in the artificial intelligence, that is the part that we are going to talk in the next minutes, we need to mention that artificial intelligence is a combination of technologies in different stages of maturity. But in order to get the artificial intelligence that is not other thing rather than enable computers to mimic the human behavior, we need to interact with 2 other factors. One is the machine learning, that is the use of statistics methods to improve with experiences, and the deep learning. The deep learning is the computational of multi-layer neural networks feasible. So we are going to analyze each of them. So for the artificial intelligence, we need to understand what is the natural processing language, NPL. From each of these topics, there are universities and companies that they are doing research, thesis about each of these ones. So I will not stop. I will just mentioning what is the key players on the artificial intelligence. The computer vision, the robotics, the sensor analysis, and also the optimization and simulation. Huge things that we need to pay special attention of each of them. For the machine learning, we need to understand the support vector machines, decision trees, Bayes learning, key-means clustering, associative rules learning, regressions, and for the deep learning, we need to enter more in detail in the core of the softwares, convolutional neural networks, a lot of neural networks, recursive long-short neural networks, and also deep belief networks. So there are so many aspects that we need to interact and play together in order to get the final artificial intelligence embedded into the system. So other important aspect is to difference between the artificial intelligence and the cognitive. I can say that the cognitive is a step behind the artificial intelligence. Very quickly, because we do not need to, we can say, mistake and thinks that both are the same, we can say that the cognitive is something behind. We can understand the artificial intelligence is going to mimic the human behavior through the developing of a ship design, and the cognitive is something that the program can learn. Here, I have explained that the differential capabilities should be understand. All the software needs to understand what are the rules, what are the operations that we are going to do with the software. We need to reason, we need to learn, and we need to interact with the user. So all these aspects need to be integrated, embedded into the system in order to get the final solution. So here is just a question for all of you. It was a question that it was done through Watson. Watson is the software that is created by IBM. Don't think that Watson is through Sherlock Holmes. It's because Watson was one of the founders of IBM. So this question is: with much gravity, this young fellow of Trinity became the Lucasian Professor of Mathematics in 1669. Some of you are thinking about what is the solution. So probably some of you recognize that is Sir Isaac Newton, no? So the thing that we need to do with a software is to try to think, to mimic how we think, no? And here is the way that we program, we develop the software in order to get the correct answer. The first thing is analyze the question. Through the natural language processes, NPL, we need to have a key element decomposition of each of the elements. Lucasian, Trinity, Professor, Mathematics, 6069. So we need to get all the decomposition. And from that decomposition, we generate hypotheses. Hypotheses about, I know any mathematics professor in 6069. If I know several of them who was working in the Trinity College or who was in Cambridge. So at the end, you have different scoring of the different possibilities that you can get. This evidence analysis is done through the big data and also through the hypothesis scoring. So at the end, the machine learning have a combination combination and answers of the different evidences. At the end, the software reverts back with an answer, telling us which is the result of this sentence that, as we mentioned, is Sir Isaac Newton. So here we have a very short video. Do you mind to click? In this video, it's just a courtesy by IBM, where it is showing how is the interaction of a prototype for a software, in order a software presented by Willow, Woodside, and we will see in this video how is recorded a live system accessing data. So it should be answered. I think that there is certain delay because the software answered him, telling what was her name, and it was not a very tough question. I think that there is not the voice. I don't know if there is certain delay, but there is answer from the software. So what the software does is to generate the different answer processes and showing all the data, all the information that the software gets from the different databases. It's a pity that we cannot listen from the other side, probably it's due to the delay of the connection. And here is showing what is the vessel and all the information. So it's perfect. So can we stop? So there are certain prototypes with accessing of certain information from the ship. So in the next slide, I would like to show the Gartner famous hype of the artificial intelligence. This hype is trying to show what is the state of the art for the different technologies. So right now the artificial intelligence we have is in the part of the innovative trigger. During the next year is going to be in the peak of inflated expectation, and it's expected that in 5 years we will have through the disillusionism. And after 10 years we will get to the plateau of productivity. This is the normal, we can say, life cycle of any of the technologies. We hope, like it has happened with the big data, that it has passed through the innovative trigger, through the plateau of productivity in just one way. So it's not necessary to follow all the technologies, but it's important to mention that there are many expectations for the artificial intelligence, which we need to analyze which are those expectations. We cannot think that the artificial intelligence is going to fix all the problems. We expect that all the problems, we cannot expect that all the problems will be fixed with artificial intelligence, and we need to identify the different use cases in order to get the solutions, the fixes for the different problems. So the current situation for the artificial intelligence, just to mention some numbers for the worldwide spending in artificial intelligence, and we can see how the different companies has been spending some money from the 2016 in this artificial intelligence, from 7.8 million to last year 19.1 billion. So it is expected dollar billions, okay? That is less than euro billions. So it is expected that in the 2022 we will get investment of almost 78% or 78 billions of dollars, US dollars, in the artificial intelligence. So if we can analyze which companies manage or invest in artificial intelligence, because all of you have listened about how the Amazon is taking all the business from the retail shops. We can also see how Cabify or Uber is taking all the business from the taxis. We know how Nokia, Kodak, companies that they were top in the market, they are now, we can say, they have not invested enough on the business transformation, so they have not been in the, we can say, in the top, as in this moment there are other companies, as for example, General Electric, Google, Apple, IBM, Tesla, Amazon. So here we can see some of the companies that they are investing money, and also they are also disruptors in the market. So there are other companies that they are more enablers and they are not investing too much. So it's important that we need to invest money, but also get certain revenue in order to continue producing the best approach for this type of software. So we need to finish quickly. So in order to create like a cognitive engineering embedded into the software, this is the technology that we are developing in this moment with the asset management through the engineering, BPA, and we have also the core of the CAD system of Foran in order to have all the different layers. The different layers that we have, in this case there are 4 layers. With the asset management, we have the different asset lifecycle management, productive maintenance. With the continuous engineering, we have the assets in engineering, the ability for planning, the integration platform. For the BPA, we have the different aspects for the processes management, robotics, and for the last layer, that is the CAD layer, we have the one in Foran. We have the initial design, basic design, detailed production, and operation. At the end, that probably this is quite high level, understanding what is required. Here is what we consider that needs to be the definition of a cognitive engineering in ship design and construction cycle. The shipyard and technical offices, competitiveness increase, accelerating the ship design cycle, and as a consequence, significant time and market and cost saving. How to do this? By integrating the IBM Cognitive through the Foran CAD. We will leverage experience, best practices, guidelines, both in vessel design and construction stages, also optimize and harmonize the design based on application design rules, increase quality design by reducing the errors, ship design construction provided expert assistance to the designer from the different early stages to most complicated ones. So at the end, as a summary of what is expected in the use of ship design into the CAD/CAM sim softwares, we can say that, for example, we need to start with some example. So some of you say, at the end, what is going to provide artificial intelligence to me if I am working in a technical office or in a shipyard? Mitigate the user errors. So something that we are noticing is that there are many user errors when they are operating with the softwares. So there are problems that there are being, we can say, placing into the 3D mockup because the user do not know correctly what are the classification society rules, ship owner rules, shipyard rules. So the companies increasingly hire lower trained personnel. This could be, of course, is some of you can be has the same opinion or not, due to high demand and lack of qualified staff. The objective, the solution will consist of an integration of cognitive capabilities without the CAD application to provide users with available knowledge for the naval design with the system, with the CAD, with the software. This includes use of the applications, applicable design rules, and lesson learned, best practices, also unexpected behavior of the software and non-functionalities provided by the tools, different assets. The activity mode could be two modes. One is the passive, later on we will see, or the interactive. We have later on a slide that will explain what is in a picture, the high level of the integration between the software and the artificial intelligence. The corpus location could be located on the shipyard, a dedicated environment, or a distributed or shared environment, where the user can access their own corpus of knowledge or can access some generic corpus of knowledge. And the capabilities, there are certain capabilities in order to manage the information. So I am a bit late, so I'm going to finish in the next two slides. Here is the picture where we try to show everything. Here we have the user and we have the user that can interact with the ship through mobile devices, smartphone, tablets, or with the PC, and with an interactive environment. The software, when the user is trying to get, for example, the user is getting or is inserting macro holes in a longitudinal stiffener. So if the macro hole is closest to 250 millimeters over a watertight bulkhead, the software is going to let analyzing the software with the different databases, with the CAD sources, with the customer knowledge, with the customer sources, with all the information, classification societies, rules, everything there. The software is going to analyze if the information that has been inserted by the user is correct or not. In this case, as the classification society says that you cannot put a hole less than 250 millimeters closest to a watertight bulkhead, the software automatically will pop up, will advise the user you cannot place this macro hole closest to that bulkhead because the classification society rules said that you cannot do it. You need to put in another position. And the other option, the other mode is on a passive way. So the user leaves the office, finish the time, and the computer in the background is analyzing if the 3D model is aligned with the classification society rules or another rules that we can integrate it into the corpus of the system. So at the end, the program will analyze and will show the day after, when the user opens the system, they will see how the model is completely, we can say, aligned with the correct information. So just the last slide, mentioning a sentence. Some of the topics could be artificial intelligence versus human intelligence. Something that is my opinion, artificial intelligence may be powerful, but always will need a human behind. And the last thing that I'm going to put is a sentence from Saturana, said, it's not what do you think, it's how you think. So thank you very much, and sorry for the 5 minutes delay.
Any questions?
I have one historic comment.
Okay.
When I was working for Shell in the 70s, they had the first class of 300,000 ton plus VLCCs. Some were built in Denmark, some were built in France, and some were built in Japan. On the Danish and the French ones, the engine rooms were a nightmare. Everything was just, it was whoever got there first put the straight pipe run in, and then whoever came afterwards had to put it round. And as you were walking along the plates, there were bridges, there were low bits, there were banging your head. Japanese ones, everything was flat, straight, laid out. They'd obviously got to the CAD earlier.
Any other questions?
Yes. Yeah, I'm managing vessel performance for Navigate.
Okay.
So we are actually getting a lot of sensor data from our ships and about 50-60 telemetry data that is coming in all the time. We've put that data through machine learning and big data analytics and everything, but the idea is to predict what is the resistance of the wind, waves and everything, but we are still unable to make an artificially intelligent model where we give it input parameters and it can predict what the resistance is going to be.
Mm-hmm.
And as you know that the hull is getting fouled as you progress along in a time series, we are seeing that the learning is not good enough. So there is some missing information, let's say about turbulent flow or whatever. We don't know what it is. So have you had any experience or use cases where you can see that this is, let's say, artificial intelligence in some other model can help address that situation?
Very good question. So the more important aspect in order to start developing, implementing a new software with the artificial intelligence embedded is analyzing the different use cases. So it's impossible right now to think that we are going to be able to integrate artificial intelligence just, sucking the hands or whatever thing. So we have analyzing different use cases. So the use cases comes from the shipyards. So there are several shipyards around the globe that they have informed us what are the major problems that they are experiencing. One of the problems is how to avoid that the users, they introduce errors in the model, because probably they are not familiarized with the classification society rules or with the shipyard rules or with the ship owner rules. So it's not the same to build an aircraft carrier that build a cruiser. So there are many things that the shipyard seen that they are producing errors in the model. So the different use cases that we analyze came from our customers, that there are the shipyards. So probably the area that you are managing is an area that is quite linked, but is not exactly the same because you do not work with the people that they are building ships in the shipyard. But for one of the aspects that you mentioned, that is the deep learning, one of the aspects that we are investing more is in how the software is able to learn. Because if at the beginning we are going to do a lot of things wrong. Why? Because the system is going to predict something that probably is not going to be the real, we can say, information. So the thing that we need to do is this information that we get from the final customer, send information to the software in order to learn how has been the misalignment. And the next time that the software is going to analyze the information, it has learned from a previous mistake. And at the end, we will have a software more clever. So at the end, it's a question of errors and answers. So at the end, it's a question of had thousands and thousands of data in order to fit the software.
Does it answer?
Yeah, I think so. It's more like improving the human factors rather than technical,
Yes,
learning.
yes.
Yeah.
And also, remember that we are at the beginning of this technology. So it's expected that in the next year, we will improve the natural processing language, we will improve the deep learning, we will improve the big data, the analytics, the IoT. So, I mean that there are thousands of companies that they are investing in order to get in specific areas, not just the software, it's also about shipbuilding, how to improve the situation, how to improve the data.
So, what?
Yeah, John Kutsopoulos, thank you for this nice presentation. My personal view is that we are far from applying this artificial intelligence because, first of all, the various CPR, the various companies have to have similar software, or they can communicate with each other, which I don't think at the moment exist. And also, what about the hardware? I mean, some companies have good hardware, some companies they don't have a good hardware because they don't have the money or they don't want to invest. So I think there is a long way to to what you have presented us. I don't know how long it is, but at the moment I think it's very difficult to.
I think that in your question there are two aspects. The second one, I'm going to start with the latest one.
Yeah.
When you mentioned that they do not want to invest, some companies.
Yeah.
This is something that needs to be clear. If we do not work together, we will not get the benefit of this. So we can have fantastic digital twin, fantastic autonomous ship, that if there is not a supplier that consumes this data, there is nothing to do. And in the other aspect, when you mention that we are far to start using, I think that we are going to be able to get the first prototype in 2020, and we will start step by step. Yesterday I used the same example for another meeting, that when someone told me for another thing that is for 3D printing, that we are far away to start using this technology. Remember 15 years ago with the GPS, that how many of us we do not believe on what the GPS let us know when said from your work to your home, this is the correct way to do it, and we say, I know better than the software where is my home, no? Or where is my working place. And we do not, sometimes we didn't believe. But right now, 15 years later, how many of us do not believe on what the GPS tells us? So I think that it's a question of trust.
Yeah, sometimes GPS makes mistakes.
Sometimes, but imagine that the GPS learn from mistakes. So this is the key point of artificial intelligence: learning from mistakes.
So one question for myself.
Yes.
How much data is required to train the model?
Okay. Yes.
Is there a large amount of information?
No, the information first. The thing that we need to do is we need to place on the corpus. We need to place all the rules that we want to be analyzed. I mean, because one ship is going to be ruled by Lloyd's, or is going to be doing by ABS, and all the rules that you would like to be analyzed. And the second thing is necessary to train the software. Train the software in terms that the same software that is being used by ship design could be used by aircraft carriers, or could be used by aerospace, or could be used by any other program. So it's necessary to train the software in order to understand that a stiffener is a stiffener, a macro hole is a macro hole, a beam is a beam. You know, it's necessary in certain way teach the software.
Yeah.
And I think that is a question of months.
Okay.
Right now.
All right.
But once you have trained the software, it's possible to continue doing. Right now we are talking about prototypes.
Okay.
We are in the beginning of this technology.
Any more questions? All right.
We have seen some. Thank you for the presentation. First of all, we've seen like nowadays the shipyards have specific designs that they sell the vessel like it's already fixed. So you go to China, for example, you want a bulk carrier, they give you the bulk carrier. Do you think that all these environmental changes and the new regulations that are gonna come, are they going to push these ideas that you have, the artificial intelligence and everything, like give a boost on these ideas and all these innovative technologies? Because there is now the space that we need to fix, like to have new designs. For example, today there was an announcement about the dual fuel VLCC. Now, there wasn't any design before that. So do you think that the moment is good now and the moment will be good for these kind of technologies to come over?
Yes, I think that is a key aspect, the one that you mentioned. There are other improvements that I have not have time to mention. One of them is now the classification societies are looking into not classify drawings, 2D drawings. They are looking in classify 3D mockups, because we lose a lot of time from a 3D model to generate the 2D drawings, that in the moment that you generate a 2D drawing and you print in PDF, automatically has lost the traceability. So we are working in order to classify 3D models, in order to improve, we can say, the process. In this, approval of the 3D mockup also will be possible that if there is a new regulation, you with an old former 3D model, you run the classification society software in order to analyze if fulfill the new rules. If doesn't fulfill the new rules, the program will tell you what are the plates, stiffness, pipes distance or nominal diameter that needs to be corrected. Imagine that the software will take their own decision in order to do that. You know, because one thing is, I think that we need to split between what is possible right now, that there are, like we can say, prototypes that they can, with a classification society rules, can analyze if the 3D model is correct. There is already in place this type of tools, and that the software can correct by their own the problems. Probably some of the naval architects here and the marine engineers, they consider that we are far away, or we will never believe on what the software is doing. I will not enter in this aspect because I am also naval architect and marine engineer, and sometimes the software has mistakes, but it's a question of confidence. How confident you are with the data that you get from a software. It's the same case of the CFDs. I do not believe that nowadays run a computed fluid dynamic software and you say, okay, it's done. You know, there are testing and testing and testing in order to
suppose all these changes that we have nowadays will affect also the inputs that you put on the system.
Exactly.
So that will be a big challenge to understand which inputs to put inside.
Exactly. The thing is, at the end, it's a question of data, because if we have done thousands of ships, we have designed thousands of ships, and these ships are sailing, imagine that all this data can be consumed moving around the different packages, and the different software can understand and learn from mistakes, from difference that we have get from the real result to the ideal mockup. So at the end, it's a question of how to handle this data. It's a question of deep learning, machine learning. It's a question of developing these tools.
Thank you.
Thanks. Any more? All right. Okay, if no more questions, okay, there's no more questions online.
Okay.
Yeah. All right, okay. If that's okay, thank you very much for
Okay.
this very informative and enlightening presentation.
Okay, thank you.
And as a token of our appreciation on behalf of the
Oh,
institute,
okay.
I'd like to
Okay, thank
hand
you.
over the certificate to you.
Okay, thank you very much.
And the usual manner, please give. And a big thank you to everyone present here and also who are joined online.